Good morning, everybody. I think it's fall. Seems like nice and crisp this morning in Boonville, Missouri. So, welcome from Boonville. What we're going to do today is talk about coenzyme Q10. And most of you, morning Eileen, Christy, I don't know, how are you all? Most of you probably have heard of it, maybe not. Um, the first person that really kind of promoted or talked a lot about coenzyme Q10 was Andrew Weil. He's still doing it. Um, and of course, coenzyme Q10 is pretty easy to find. It's come down in price. It used to be quite a bit more expensive. Hi, Jen. And if you want to spend some more money, you get the better absorbed ubiquinol, and we're going to talk about all that and what it means for you, really. So CoQ10 used to be about $30 a month. You can get it for about $18. The ubiquinol, which actually is the kind of active antioxidant form, is still up there around the $30 to $35 for 30 days price range. So what is it? What's the deal? Okay, so when you're young, and of course I focus on people as they get past 40, my little teeter-totter analogy, and 40 is the fulcrum of the teeter-totter. So young people really don't need to worry about coenzyme Q10 because it's made in your body. It's found in all human cells. The other name for coenzyme Q10 is ubiquinol or ubiquinone. So ubiquinol is the reduced form, ubiquinone. So it's a ubiquitous, because that's the way they named it. It's ubiquitous. It's found in all human cells. So I put you up a picture of a mitochondria, which is where most coenzyme Q10 resides. And I've talked to you about mitochondria and what they do. If you want to know all the biochemistry and all the real picky details, then enroll in my physiology course at State Fair Community College, and I'll teach you. So it plays this. So when we talk about mitochondria being the energy production of the cell, coenzyme Q10 plays a substantial role in that. So it's an electron carrier in the electron transport chain. There's the physiology part and the biochemistry, and then outside of the mitochondria, coenzyme Q10 is an antioxidant. So it works together with vitamin E and all the other antioxidants we've talked about. Okay, so it works synergistically, meaning together, with all the other antioxidants, including vitamin E. Okay, so it's widely available. It's gained a lot of attention over the years for the possible therapeutic use in certain metabolic diseases, typically type 2 diabetes and mitochondrial dysfunction, which becomes more common as we age. So the CoQ10 lecture today is really for people that are over 40, especially in the 50s, past 50. You just don't make it as well as you used to, just like almost everything else that goes on. It's used so coenzyme Q10 is used in cardiovascular disease, diabetes, Alzheimer's disease, Parkinson's syndrome, Parkinson's disease, and cancer. And it appears to help protect you from some of the nasty problems that people taking statins tend to trend toward, I guess is the best way to say it. Okay, so ubiquinone or coenzyme Q10, it's vitamin-like, it's a nutrient, it's lipid soluble. So when you ingest it as a supplement, it has to be carried and absorbed in the small intestine using the same way that we absorb fats and lipids. So that's chylomicrons. That's also biochemistry and human physiology. So it's primarily located in the mitochondria. It's also in the cell membranes, and it's carried by low-density lipoprotein, my little cholesterol taxis that we talk about. So, of course, if you lower your LDL, like we do with statins, you actually decrease your coenzyme Q10 availability to transport for your health, right? So its primary function, cellular energy. Okay, and it has to, it reduces. So ubiquinol is the reduced form, is the one that is the free radical scavenger. Okay, so remember, we talked about this before, mitochondrial function produces reactive oxygen species. So you need some of those because that's part of your fighting off pathogens, et cetera, et cetera. However, as you get older, you have less ability, especially if your coenzyme Q10 goes down, you have less of the ability to clear the reactive oxidation species, and that causes oxidative stress, damages lipids, it damages proteins, DNA, overall functional status of the mitochondria just from doing what it's supposed to do. But you have to have NAD and you have to have coenzyme Q10 and all the things that we've talked about involved in mitochondrial function. And then if your oxidative stress gets high enough, that's what leads to chronic disease and inflammation. Okay, so CoQ levels decrease with age, so you have less antioxidant power. You're increasing your reactive oxygen species, and then you get an age-related oxidative stress that can develop into other metabolic dysfunctions and chronic illnesses. Okay, so it was first discovered, coenzyme Q10, isolated and characterized in 1955 in Liverpool in the United Kingdom. They elucidated the chemical structure. We're not going to go through all that because I would bore you to tears, which I might be doing anyway. So it was found to be deficient as they studied this. It was found to be deficient in patients that had cardiovascular conditions, so hypertension, angina, congestive heart failure, people who've had heart attacks. And in 1975, a guy named Dr. Peter Mitchell had a theory that ATP, so that's your energy source from mitochondria. So phosphorylation of ADP to ATP is what drives the energy sources that are needed for reactions in your cell and across cell membranes. So Dr. Mitchell felt that the ATP synthesis created an electrochemical gradient. Okay, so a biological energy transfer in which coenzyme Q10 was required and necessary. He won the Nobel Prize for that theory in 1978. Okay, so it is naturally occurring. It is made within your body. It is very difficult to get enough coenzyme Q10 from dietary sources. Okay, so dietary sources, I mean, we talk to nutritionists and dietitians and all that. How do we eat healthy, et cetera, et cetera? Well, you can't necessarily eat enough coenzyme Q10 to help with your endogenous or within your body production. So 95% of coenzyme Q10 is present in ubiquinol, which is why the transformation of the supplement from coenzyme Q10 to ubiquinol was driven because ubiquinol is better absorbed if you take it as a supplement. Okay, and you can do a ratio of ubiquinone and ubiquinol in blood tests, and it's a measure of oxidative stress. Okay, so aging and certain disease conditions minimize ubiquinol levels in the body, probably because of increased oxidative stress, and you lose the ability to reduce ubiquinone, and you have a lower amount of total coenzyme Q10 running through your body. Okay, so the tissues where mitochondria is significantly providing respiration, generation of adenosine triphosphate, ATP. So the highest levels of CoQ10 in tissues are in the heart, the liver, and the kidney. Okay, also the brain. But when I tell people that your CoQ10, that taking a CoQ10 supplement or a ubiquinol supplement will improve cardiac muscle function, that's why, because your heart probably has the highest level of necessary generation of ATP for heartbeat, and you have a huge amount of mitochondria and coenzyme Q10 in your heart muscles. So there's gels, there's all kinds of ways to get coenzyme Q10. Most people, I mean, gels are pretty easy, except they're kind of nasty sometimes. And so most people want to just take a capsule, right? Probably the worst way to take a supplement is by capsule. That's why I like my shots when I tell people about my blends. My latest is the mini skinny shot. For people that want to do the super skinny shot, which is more expensive, but the mini skinny shot, you're taking what you need to help with your weight loss journey in an injection, so you don't have to worry about losing a bunch of it in your feces or having it go through your liver and being remetabolized. Okay, so the food sources, it's widely distributed in nature, so it's found in plants and animals. So animal products have the greatest amount of coenzyme Q10 compared to other types of food. The supplements originally were based on ubiquinone powder, tablets, capsules, oil-based soft gels. The bioavailability of those are poorer than ubiquinol-based formulations that are more stable and have more bioavailability, so they're absorbed better. So there's Q gel, there's Qnol, there's Canica QH, and then there's ubiquinol as a capsule as well. The doses, 15 to 100 milligrams. Dr. Weil, many years ago, 20-some years ago, said if you're not taking 100 milligrams of coenzyme Q10, you might as well not be taking it. So 100 to 200 milligrams is kind of what most patients take just for age-related reduction in coenzyme Q10 production in their body. Larger doses are pretty well tolerated. So there's patients that have pathologic conditions such as heart disease, neurodegenerative disorders like Parkinsonism and Alzheimer's, cancer, diabetes. It's safe, minimal adverse effects. Dosages from 600 to 1200 milligrams, which are used in Parkinson's disease and Huntington's disease, no adverse effect. And then there was a study in Parkinson's disease where they were studying 3,000 milligrams of coenzyme Q10 for the effect on neurodegeneration of Parkinsonism. Okay, the best way, and nobody's going to do this, but the best way to tell how much CoQ10 you have endogenously being produced is a muscle biopsy of skeletal muscle. And I'm thinking there's not even any doctor that would offer to do a skeletal muscle biopsy to see how your CoQ10 endogenous production is. Okay? So again, since it's in the mitochondria, the main function is energy production. There's a whole bunch of biochemistry about that we're not going to go through. If you want to do that, I'll start a biochemistry class at State Fair if they'd let me. But we don't need to go through all the biochemistry. I have a chemistry degree and I have a hard time following some of that. So in the reduced form, ubiquinol, which is 95% of what's carried in the blood by LDL, somewhat by HDL, you have about 1.5 to 2 grams running around through your body and your bloodstream. And your dietary consumption per day is only about 2 to 3 milligrams. So about 1,000 less than what you're carrying around. 1,000 times less than what you're carrying around in your bloodstream. So, 1,000 times more of CoQ10 has to be made inside of your body. And you lose some of that ability as you age. Okay, so in the reduced form, that's involved with electrons and donating, getting rid of the reactive species of oxygen that increases with oxidative stress with age. Okay, vitamin E plays a role, and the interesting thing about coenzyme Q10 is CoQ10 has the ability to regenerate vitamin E if vitamin E attaches to a free radical to get rid of it. So it changes the chemical structure, and CoQ10 rushes in and regenerates vitamin E. That's also one of its functions. So the ubiquinol form, 95% running around through your bloodstream, is running around trying to get rid of the free radicals that are formed from normal respirational activity. Respirational is not a word. Respiration activity of creating the energy source for your cells called ATP from mitochondria. Okay, so what about in disease states? So cardiovascular disease still the number one killer, cause of death of Americans. One death every 40 seconds in the U.S. If you lump cardiovascular disease, that includes hypertension, high blood pressure, heart failure, coronary artery disease. And coronary artery disease, what leads to heart attack, that's 1 in 6 deaths, pretty much. Okay, so despite all this statin stuff and we're going to prevent heart disease, that's not happening. The death rate's gone down because we've gotten better at treating heart attacks in the emergency room, keeping people alive. But the actual attack rate is about the same. It has been for 40 years, despite all these goofy food recommendations that we've gotten from the food pyramid, which I've talked to you about ad nauseum. Okay, so CoQ10 appears to be an effective supplement with other compounds with coronary artery disease patients. There's a bunch of studies on that. Most cardiologists tell patients, well, I guess I shouldn't say most because I haven't talked to most, but many cardiologists pretty much routinely will tell people when they get to be 40 to supplement with CoEnzyme Q10. Friend of mine in Oklahoma City, pretty routine. He's one of the reasons I started looking at CoEnzyme Q10 and what it did. Okay. Coenzyme Q10, along with the vitamin B6, which is part of the complex vitamins, stress vitamins, vitamin B6 is a precursor for synthesizing coenzyme Q10 in your body. Okay, so theoretically, I guess you could just take vitamin B6, but coenzyme Q10 is formed from tyrosine, one of the amino acids. Okay, so what they see is with a reduction in stress, oxygen reactive species, it's actually reactive oxygen species, supplements with CoQ10 has had success with shorter hospital stays for patients having surgical procedures involving cardiac blood vessels, specifically coronary artery bypass graft. And that was at 150 to 180 milligrams of CoQ10 a day for 1 week prior to a bypass surgery. So fewer arrhythmias, fewer blood requirements, and less drainage from surgery inside the chest. So it tends to reduce, there's a thing called ischemic reperfusion with bypass patients. So it takes a little while to get that bypass graft to do what they want it to, and CoQ10 helps that do that. Okay, there are mitochondrial dysfunctional diseases because of mutations. Remember, mitochondria has its own DNA from your mother. And so your mitochondria, due to continued reactive oxygen species doing what it's supposed to do for a living, can lead to mitochondrial dysfunction. And the mitochondria has a role in telling the cell, if it can't be repaired, that it needs to go ahead and commit suicide. That's called apoptosis. We've talked about that. That's way more common as you get into your 50s and 60s, and it's an age-related thing. Okay. What about diabetes? So we know diabetes, 7th leading cause of death, or complications of diabetes, 7th leading cause of death in the U.S. So it's a vascular thing, and inflammation and oxidative stress is a big deal in diabetes. So diabetics tend to be deficient in plasma coenzyme Q10 compared to people who do not have diabetes. Okay, there's also a reduced ratio of ubiquinol to total coenzyme Q10. So remember, ubiquinol is 95% of what you're carrying through your bloodstream, usually on the LDL lipoprotein taxi. Okay. So people with type 2 diabetes, they get a benefit from the antioxidant action of coenzyme Q10 since their levels are reduced. Um, and the impairment or the lower level may be from, well, the lower level of ubiquinol is probably from the impairment of the ability for your body to create ubiquinol from ubiquinone, which is coenzyme Q10, right? So they've shown improvements in hemoglobin A1C levels and prevention of glucose-related end products, which can lead to kidney damage, which is kind of a big deal. CoQ10 does not affect your lipid profile. It does not affect your blood pressure, so it's not considered a supplement that helps with those. Okay. Also, diabetics with congestive heart failure have been shown to have a better outcome with CoQ10 supplementation. We talked just a little bit about Alzheimer's disease and neurodegenerative diseases like Parkinson's and Huntington's disease. Also from mitochondrial DNA damage. That's not the whole story. But the DNA in the central nervous system tissue is like in most cells, it's in close proximity to those reactive oxygen-free radicals. So any dysfunction to the mitochondria in the central nervous system can cause irreversible mutations of the genes that synthesize ATP for your energy. Okay, so oxidative damage can cause permanent changes in how you produce energy in your body. And then again, that leads to cellular suicide or apoptosis. So what they found is Alzheimer's patients and Parkinson's patients have decreased concentrations of coenzyme Q10. Okay, in cancers, based on that research in the 70s and that theory about CoQ10 being required in the electron chain transport and normal cell respiration. So any loss or decrease in the availability of CoQ10 can alter cell function, leading to inflammation, oxidative damage, and once again, that is a start toward the development of different cancers. So observationally, a study reported that people with lung, pancreas, and breast cancer are shown to have a lower plasma coenzyme Q10 level compared with healthy controlled people. So there's that controlled study. It's observational though. It wasn't a randomized. Let's do something and see if it gets better. Smokers have a lower coenzyme Q10 level, particularly in people who have a risk of cardiovascular disease and chronic heart failure. Okay, so there's not really much research on smokers who have none of that history. Does CoQ10 help prevent the onset of the risk of cardiovascular disease and chronic heart failure? No studies showing that really. And really, there's not and we'll get into the statin thing here in a minute, about the studies with statins. So exercise seems to be that, CoQ10 may help you recover from exercise. And of course, there's benefits to exercise with lower risks of developing chronic illness and overall mortality from those illnesses. And so if you increase the intensity of and the duration of an exercise, you get fatigue, potential muscle injury, and so CoQ10 supplementation about an hour before a heavy exercise may actually scavenge the antioxidants that can cause that fatigue and muscle injury. Okay, so it has a place potentially in that, but again, very few studies on CoQ10 supplementation in high-intensity exercise workouts. I'll have to ask Tammy, my personalized fitness and physical fitness trainer person, if she uses that, because she's pretty intense on her exercise. So in strenuous, so we're talking about like marathon running and intense aerobic activity, cycling. The concern is damage to muscle cells because of progressive oxidative stress and inflammation. So CoQ10 potentially could decrease that. Okay, so what about the interaction with statin, which is kind of where I was headed with all this. So now you got the background. Okay, statins are now required to be labeled to raise the risk of type 2 diabetes. And of course, type 2 diabetics have a lower CoQ10 level, right? We talked about that. And statins lower coenzyme Q10 levels. So it's kind of a vicious circle. So you're trying to prevent heart disease, which I've shown you doesn't work, in patients with higher cholesterol levels and LDL levels. And we've talked about the levels in people 60 years and older, and what those should be for a potentially longer life. So the lower your cholesterol and LDL levels are, and remember LDL carries coenzyme Q10, then the less CoQ10 is available to your body. Plus you're raising the risk of type 2 diabetes and sugar control problems. So 60% of coenzyme Q10 is carried by the LDL taxi. Okay, and every time I read about this, people say LDL cholesterol. LDL is not cholesterol. It's a lipoprotein. It's a taxi. So when I even see that on labs, LDL cholesterol, HDL cholesterol, they're taxis. They're not related to cholesterol. They carry cholesterol. And LDL carries 60% of the coenzyme Q10 running through your body. So statins really counteract the ability of CoQ10 to do what it does and to reduce your antioxidant activity. If you are on a statin, you need to be on coenzyme Q10. It lowers the levels. It raises your risk of type 2 diabetes. It raises your risk of chronic inflammation. Okay. So that's the story with statins and CoQ10. So the FDA has added, as of 2012, several things related that happened to what we've talked about on the labels for statins. Okay. Okay, so let's review. I told you what I'm going to tell you, then I told you, now we're going to tell you what I told you. CoQ10, it's synthesized in every cell of the body. It's a vitamin-like compound. Mitochondria have the highest concentration, and mitochondria provides the energy for cellular respiration in the form of ATP. So the tissues that need that the most is the heart and the muscles, skeletal muscles, when you have high energy requirements, especially if you're exercising. And then outside of helping with respiratory energy production, as a reduced form, ubiquinol acts as an antioxidant to reduce the damaging effects of the side compounds of respiratory energy production by mitochondria. Okay? So contribution through diet is not usually necessary and doesn't actually work. So absorption from dietary CoQ10 from animal and plant products is not very efficient because of the weight of the molecule, etc. So you have to, if you're going to supplement, you have to take, or if you're going to have a good one, you have to take coenzyme Q10. And preferably you take ubiquinol. Okay, so we've done 29 minutes on CoQ10, huge supplement. I'll put up the link, when I get done, I'll put up the link to the article from which I got this. And you can read all about biochemistry if you want. You can see all the citations that are on there. And then we will reconvene Friday morning at 9:30. I haven't picked my topic yet. So thanks for joining me. It's a great day outside, so I'm going to maybe do some garden stuff since it's not blazing hot right now. And I will talk to you Friday. So peace and health to all of you. Have a great day. I'll see you Friday. See you later. Bye.